Happy Cody, Bob Thompson. So, today we're going to be messing with some array variables, but not just any. We're going to be messing with character arrays. So this is something that I've been recently up to, and I've done some neat stuff with it. So let's see how it goes. So basically, I'm going to start out by titling this video Happy Trees. Since characters themselves are actually trees. So that's the title of this program, Happy Trees. So basically after this we're going to make our character variables. Character, I'll make it star to make an array. And then I'll make it, let's say car. Since that's what a lot of people call it. They go like chars or cars. So as characters, you say care. Pictures, you know, like that. Okay. Enough of my stupid humor. So basically, when you make a character variable like this, and you make it a pointer, it's going to contain a set number of values in it. So, let's see how it goes. So, this is the happy tree variable. So, that's what's named right now. The problem is we can't make any changes to it. But we could display it right now for our own conveniences. So, car and Dale. Because I like to use and Dale instead of /n. I just find it a little easier. But let's see right here. So right now, happy trees. This is a happy tree variable. That's how we know what we're messing with. It's always good to put that in your program so you know what you're looking at when it outputs. So right now, we have a car variable that is an array, and it holds a lot of spaces. So you might be asking yourself, wait, this is an array, this is a pointer. Well, both pointers and arrays are very similar things. But yeah, this is basically an array, and it just has this attached to it. The only thing is we can't really change it. This is basically almost like a constant. You can't like change like any of the letters. So let's say. So right here I am making the 0 spot of car, which is the first spot, equal to P. So that's a character P right there. Let's see if this works. See, there's an issue. Because we're trying to access a part of the array that just can't be changed. So, it's this line of code right here. See, we can't change that. We can't change the first one to a P. It'll be fis. Okay? Let's shake off that mouse. Let's get into it. So, as soon as we take that out, it works just fine. See? Return 0 and everything. That's how we know it finished right. So, happy trees is a happy tree variable. Now, how do we change that? What happens if we want to say this is an unhappy tree variable? I don't know why we want to say that, but let's say we do. Well, first, we want to be able to, since we can't change it, we need to do something else. We need to point it to a new variable. But I'll show you how to do that right now. I'll name it changer, and bam. Make a little prototype up here, happy little prototype, and let's pass that car variable in here. Say to C, or C's, to make it, plural. And we want to specify that size up here. So I just call this length, since that doesn't override anything that already exists in the code. It's the only problem with using namespace std. What we could do is we could take that out, but right now I just don't feel like messing with having any problems with it. So right now, I'll shake off this mouse, and then I will copy this and paste it down here. Bam! So now we have that function down here. Right now it's not doing anything. Nothing's in here. Okay? So what we need to add something in there. And then we're going to make a character variable in there. So we just have this right here. But, oh wait, our parameters are just copies of the original variable that's being passed in. So right now, this might be a pointer, but it's actually a copy because we're passing a string in. That's how C++ sees it. So what we need to make this pass by reference first thing. Anyway, that's what I do. So, right now, we don't have a copy anymore. We're just passing that variable in. Passing an alias. That's what I like to call it. That's what one of my teachers said to me when I was in college. But yeah, let's see this. So right now, we just have nothing going on in the function. We need to make something go on. Besides that comment up there, of course. And then, so I'll do that by doing this. A new character. I'll name it car again, just like I did up here. But since it's in this function, we'll have to worry about the namespace. Okay. Car equals new car. Wait. So the reason I'm doing this is because I want to make that new variable on the heap. I don't want to make it on the stack. Because as soon as it gets out of these brackets, it's bye-bye. Bye-bye time. And that's not happy. That would detract from happy coding. That's all I gotta say. So let's see if this runs before I actually do anything else. See if it has any compiling errors. No compiling errors. And of course no runtime errors since main hasn't been changed yet. But actually, let's just say I want to change main real quick. So I'll put the changer in here. And then I'll put CS, well that's car, and then I'll put the length in here, the new length that I want. So right here, it's about 31 places, plus the null character, so it's actually 32. So what I want to do is I'll make it double that. Nice little square root. And I'll make another string, add it on top of that. I'll name it car add, and this will be on top of our old string. So right now I'll name it as a happy tree variable. In the happiest place in the world. So how long is that? 69. Let's say that. That's a nice little number up there. There's two directions it's going, doesn't know where it's going, but that's fine. Okay, so now we have our second string that we're going to add on to our old. You could pass it in from main, but right now, we're not really worrying about that. I just want to show you how to resize that variable. This is already the first step right here. We have a new one. Okay, so next, we have a new variable, but how are we going to get old values? We want to add something onto it. We don't want to just not do anything with it yet. So, right now, I'm going to make a for loop. Now, for loops, they're just like loops. Length, yep, that'll work. Plus. For loops are just like while loops, but the difference is you have a starting part where it initializes a new variable, which will be the counter, and it'll have the increment part right here. So I'll add one extra each time it runs through the loop, as long as I has less than length. So we want to add all of CS into our new car variable. That's in changer, not the one in main, of course. So I'm going to say if I have less than length divided by length. This might not work out very well. What I could do is I could just cheat and put an old length in. So I'll put the old length of the this isn't the right way to do it, but yeah, let's just do it. Let's get it done. This is our first attempt anyway, together. You and me. Okay, let's see how this goes. Length, it's only prom. Okay. Bam. I think I spelled it the same. Okay. So if I is less than length, what do you do? I mean, if I is less than old length, what are we going to do? Well, what we want to do is we want to add all of the old CS into the new car variable. Let's do that. So car, what I'm going to do is I'm going to do it a different way. This is the way I'm sure it's going to work. So car plus I. So if you're not sure what this notation is, it's basically saying here, okay, so at the address of car plus I, which is the size of the character variable, which is about a byte. This is 1 byte. We'll add I by that much and then get the contents of that address and use it here. So right now it's not going to like bring us anything. Right now we just have garbage values in there. But we're going to put some happy values in there instead from the old part. So I'll do the same thing with the CS variable since it's basically the same. Now I greater than or equal to old length. Well, first of all, we're going to overwrite the null character. That's in the old variable, because we don't need it right in the middle. That'll mess up a lot of functions that a lot of people like to do. Because what a lot of people like to do is they like to kind of move through the function like this. Like, let's say we want to access that part of the variable right here. There's another notation, by the way. If CS of I does not equal null character, keep going on through this loop. Like, you want to do stuff with a loop. So let's say you want to print it out. This would be one way to print it out and just define the end. But right now we don't really want to do that. So instead what we're going to do is we're going to get the car plus I. Oh yeah, I need to make another counter too. Because we want to actually be able to access every little bit of this. So car plus I is still at the same point of memory. Gets the contents car add plus counter. And after that, you get increment counter because you want to move like I does, but it's only going to have the increment's only going to happen when I is greater than or equal to old length, because we don't want it to happen in the other one, or else it's going to be pointless. So with this logic right now, basically what's happening is when I is less than the old length of the array, we're going to put like everything from this old variable CS, which is a car in main, into the new variable car and change it. And then when I is greater than or equal to old length, then we're going to add everything from the new variable on top of that old array. So right now we have some working functions, but the only problem right now we're just making changes to the new variable. We're not making changes to the old variable. So what we need to do, since we did actually pass in the old variable into this function with the reference, then we need to, after that, we need to delete the old variable. What that does is that deallocates all the memory that's contained by CS so that we don't have memory leaks. Because once the stack leaves that part of memory, it's not going to be able, it's going to think that memory is used up. And then we're going to keep using up memory until the program has no memory to use. And then the program will crash at runtime. We don't want that to happen, so we're going to delete all CS. And then, after that, we are going to give CS the address of car. That's how you do it. Basically, we're giving CS the position of the new array. So now CS is that new array. Even though the new array exists as long as it's in this stack frame. Right now, it's going to be out of stack frame. So this old one is not going to be used anymore. But is this a pointer to an address anyway? And we're pointing this to the old address. So, to the new address. Basically what we did, we just resized it, gave it a bunch of new old things, and then, oh yeah, but I forgot to do one thing. Length minus 1. Wait, is that it? 69. Yeah. Length minus 1 equals a null character. We need to give it a null character at the end so it'll work with those loops. Okay, so now we got that all done. Now it contains everything and a null character. So we know where it's going to end. And let's try displaying it again. Let's see if our change is lasted outside the function. I might have made a couple mistakes. Let's just roll with it if I did. Of course, I did make some mistakes. Okay. Yeah, I have to pass the size of the old array in. I forgot to change the color. That's the thing about these. There's always little mistakes in there. You don't have to worry. Okay, so the old size of it was 32. Boom. So it actually changed it. So right now, it's saying happy trees. That's the title of the program. This is a happy tree variable. And this is a happy tree variable. And appended to that is in the happiest place in the world. So this has been Happy Coding. I'm Bob Thompson. Thank you for coming today. Let's shake off that mouse for a goodbye sesh. Yeah.